Welcome to the Explainer. Right now, wherever you are, I want you to do me a quick favor. Take a really deep breath in. Hold it for just a second. Now let it out. Feels pretty good, right? We literally do it thousands of times a day without even a second thought. But what if, in the blink of an eye, taking that next breath became completely impossible? What if the invisible shield keeping every living thing on this planet alive just vanished? Okay, let's dive into this catastrophic hypothetical scenario. Imagine it all just vanishes in a millisecond. One moment you're sitting there hanging out, listening to this explainer, and the very next, absolute vacuum. It's a completely jarring premise, I know, but exploring a scenario this extreme actually helps us figure out exactly what our atmosphere is doing for us every single second of the day. And, as you're about to see, without it, things wouldn't just go wrong slowly, they'd go irreversibly wrong almost instantly. Section 1. The atmosphere vanishes. Now, what's really interesting about this invisible shield is that it isn't just empty space up there. It's actually a precisely balanced chemical cocktail. The lion's share is nitrogen, making up about 78%, followed by the 21% of oxygen that our bodies desperately need to keep functioning. And then you've got a tiny sliver of other trace gases. This specific recipe isn't just some random accident. It's absolutely essential for life as we know it. It regulates the global temperature, blocks out harmful space rays, and literally provides the fuel our cells use to survive. Take this mixture away and the entire system crashes. Section 2. The first few seconds. Let's speed things up now. If you blinked, you'd literally miss the beginning of the end. The sheer, utter panic of these initial moments is honestly hard to overstate. At 0 seconds, the air vanishes. By 1 second in, total, deafening silence. Sound actually travels by vibrating through air molecules, so no air, no sound at all. You didn't even hear the chaos erupting around you. Then, just 3 seconds in, we hit a sudden, devastating drop in air pressure. You see, the weight of the atmosphere is constantly pushing down on us, holding everything together. When that pressure abruptly disappears, the physical environment shifts in a violent blink of an eye. So what does that sudden drop actually mean for us? Well, to put it mildly, the human body is absolutely not built for a vacuum. First up, obviously, there's an immediate inability to breathe. But guys, it's so much worse than just holding your breath. That severe lack of oxygen would hit your brain almost instantly. Combine that with a drastic drop in pressure. Without external air pushing inward, the gases inside your body would rapidly expand. It's this terrifying phenomenon known as ebullition, where the liquids inside your body effectively start to boil at room temperature. Because of this horrific combo of 0 oxygen and 0 pressure, the time a human could survive is practically 0. You'd lose consciousness completely in a matter of seconds. Section 3. Environmental collapse. So, we've looked at the microscopic scale of human lungs. Let's slow down for a second and zoom way out to the macroscopic scale of the entire planet. With our atmosphere, we get these beautiful blue skies because gas molecules scatter the sun's light, a really cool process called Rayleigh scattering. We also get balanced temperatures and functional weather systems bringing rain and wind. But remove that air, and the sky turns instantly black, even in the middle of the day. Without air to trap and move the sun's heat around, we'd suffer extreme, rapid temperature changes. You'd be freezing cold in the shade and boiling hot in the sun. And the weather? Completely gone. Weather systems would collapse entirely because, well, there's no air to move around. All of this triggers a cascading chain reaction of devastation. Step 1. Because of that sudden drop in pressure we talked about earlier, water on the planet's surface would actually begin to boil and evaporate over time, just turning straight into vapor. Step 2. Without liquid water, carbon dioxide, or any protection from the elements, surface plants wouldn't stand a chance. They'd die off incredibly fast. Step 3. With our protective atmospheric shield gone, radiation from the sun drastically increases, completely bombarding the planet with lethal ultraviolet rays. Section 4. A lifeless planet. Once that immediate chaos subsides, we're left with the long-term aftermath, a silent, haunting planetary decay. As the days turn into years in this bleak future, the oceans slowly disappear entirely, boiling away into the void of space. The vibrant blue and green Earth that we know and love transforms into a barren, lifeless rock. Stripped of its atmospheric padding, the surface becomes incredibly harsh, physically unstable, and totally alien to anything we'd recognize today. But wait, could anything at all survive this apocalypse? Well, for humans and surface plants, extinction is immediate. 0 chance. But deep underground, or way down at the bottom of the ocean, it's a slightly different story. There's a tiny possibility that underground life might cling on for a bit, totally shielded from that intense solar radiation. And incredibly, for deep sea life and certain extreme microorganisms, survival is actually possible. They don't rely on the surface atmosphere the way we do, and the deep ocean might provide just enough pressure and shielding to let them outlast the surface apocalypse. It's a pretty stark reminder of just how fragile our specific existence is when you compare it to the resilience of deep-sea bugs. Section 5. Our gravitational shield. So the crucial point here is, before you start panic buying oxygen tanks for your basement, here is the scientific reassurance you need. Gravity is the absolute hero of our story. It's the fundamental physical force that keeps Earth's atmosphere firmly anchored to the planet. You see, the Earth is massive, and its gravitational pull constantly hugs that blanket of air right to the surface. Because of this massive, unrelenting force, a sudden, spontaneous loss of air is scientifically, practically, and fundamentally nearly impossible. Our atmosphere isn't just going to float away on us. It all boils down to a brilliantly simple truth. Air is absolutely essential for life. Walking through this wild simulation shows us exactly why. Every single component, from the pressure it provides to keep our blood from literally boiling, to the oxygen that fuels our brains, to the shield it forms against the hostile environment of space, is just incredibly vital. So, I'm gonna leave you with this. Next time you take a deep breath, will you remember the invisible shield keeping you alive? It's so easy to take for granted because we can't even see it. But that mixture of gases wrapped around our world is quite literally the only thing standing between us and the quiet, dark vacuum of space. Thanks so much for joining me on this thought experiment, and I'll catch you on the next explainer.